Today we will start this air pollution and the effects of air pollution, and in this we would discuss about the different types of air pollutants. But let me, before I go in to explain this, let me introduce to you to the subject and the importance of the subject as such. See, air pollution is over the years, for last 10 years or say for about for about 2 decades now, there has been a tremendous growth of air pollutants, which are many of which are in the circulation. As you know, as I was discussing, in the beginning also, in many cases, the natural processes which generate these air pollutants and the artificial processes like the man-made processes that generate air pollutants both have some similarity, but the only difference is in the matter of quality of the pollutants as well as the quantity. The quantity being in a natural stream, in a natural situation, the quantity is much less. Quantity is and the quality is also relatively better, because I will discuss more and more on what are the types of pollutants we are producing now. Many of them were never heard before. Many of the air pollutants, the critical air pollutants today, were not heard before, say only up to 10 to 15 years back. They were not heard even. Those kind of pollutants we are now generating, and they have tremendous serious impact on the health and the life of humans. We will mostly discuss this, as I have said, air pollutions, we would deal with them mostly with the related to the effects on human. We will not be in a position to know more about the effect on the other animals like the cows, the dogs and the cats, what are the other effects, but we can the similar studies are now being found where the impacts of these pollutants on the other animals are also being studied, and it has categorically shown that this has there is an effect, there is a serious impact on the air pollutants. Like let me tell you very visible examples of air pollution and other related pollution effects is in most of the cities now you will not find small birds anymore. The small birds that you see here in Kharagpur, maybe particularly if you wake up about say 3:30 in the morning, or say even if you just observe at the afternoon, say about 5:30, you will find lot of small birds around. I mean, mostly these small birds are no longer seen in the cities. The reason being is, one of the reason being is mostly the most of these birds and the creatures like that, they have a very small blood volume. So the mass of blood in them is very small. So they react very fast with the change in the air pollutants. So there is small absorption by the blood stream of the small animals can alter their lifestyle, alter their living pattern. So you will find mostly it is with the damage in the of the habitats of the birds and other animals, as well as along with the typical aspects of air pollution. We find today that the most of the birds are not seen in the cities anymore. So similarly, only you will find the crows or some larger birds, but small birds like sparrows, you will hardly find sparrows in cities anymore. Because of tremendous growth in air pollution. There is a tremendous growth in air pollution. Trying to understand this, I mean, what are the typical impacts on human? If the impacts on human, without having to know much about air pollution, you can still say that say there are more breathing disorders in the city population today. Many people suffer from asthma related disease, bronchocardial diseases. Many people suffer from typical say like allergens related diseases, where the allergies take place, different types of allergy, cold allergy, irritational allergies like skin irritation, eye irritation, all these kind of things take place, and they are actually growing in number, and their effect has been wide across. More importantly, particularly in the cities areas, likely where there is a dense population as well as there is a dense traffic, and also there are, say, particularly in those areas you will find that combustion of fossil fuel is also more. In such situation, mostly the children who are born of these situations, they are likely to be born with retarded brain growth, retarded brain development. So there are direct and indirect effects. Some of the effects of air pollutants are clearly visible, that you can see before your eyes, and there are many of the effects which are not visible, which might be apparent, say, 10 or 15 years after a person is exposed or consistently exposed. So we will briefly study about them, the typical types of this kind of pollutions and their effect. To sum it up, since we do not have much time left to discuss about these air pollutants, let me go straight into the aspects of air pollutants. So here we will briefly discuss about the typical types of say the sources and the typical sources and the type of common air pollutants. Let us start from, say, common air pollutants. Common air pollutants. I will also discuss this with respect to different industries. Say is pollutant. This is pollutant source. Say related industries or uses, or typical uses that we can deal with. Say one of the large say a largely affecting pollutant is sulfur dioxide, SO2, that we know of. This is a colorless gas produced, say, due to from coal combustion, coal and oil combustion. Because coal and oil combustion, as you can see, mostly say coal and oil naturally would contain some sulfur, as I was discussing in the case of limestone, or in the case of many other minerals that we know, there will be always some sources of sulfur. So sulfur, when it is being smelted, when it is put in a smelter, when it is fried and burnt, so this sulfur would easily convert into sulfur dioxide, and that would be related. This is a respiratory irritant. See, all this kind of power plant, kilns, then say all this other energy producing power plant, kilns, wherever there is a steel plants. So almost all kind of industries somewhat related to sulfur dioxide, it brings out a certain level of sulfur dioxide. Similarly is nitrogen dioxide, some of you might be knowing. Say the most important, say the vehicular pollution, vehicular combustion, say, as you can see, this mostly all these vehicles, power plants, and also particularly different other sources like say refractories, say here, say any other, wherever we are using, say, liquid fuel, we would create nitrogen dioxide. Anywhere, say any other, say, repair shops, etc. So you can see all these places this kind of nitrogen dioxide would be produced. Remember one thing, nitrogen dioxide all this, as is this sulfur dioxide has a potential to become sulfuric acid or sulfurous acid and sulfuric acid. Nitrogen dioxide has a capability to form HNO3, which is also acidic in nature. So all this, particularly when it is formed, they have one important aspect is NO2 particularly has, a work in a synergistic effect in sometimes with atmospheric ozone. So, it's basically related to these two together. The effects of two together is more than the sum of each individually, right. So, it is basically is equal to 1 plus 1 is more than 1 plus 1 is more than 3, more than 2, like this. So, here the effect of two together synergistically is more than one individually, say more than the sum of each individually. So, this has great effects. We will study some of those, say H2S, sulfur dioxide, say this refineries, mostly refineries, all these chemical industries, So, it is refineries and chemical industries are particularly related to so all say chemicals preparation, all where this chemicals preparations is generally done, the H2S will be obtained. Say it is a carbon monoxide as you know, say burning of coal, gasoline means petrol or diesel, say then motor exhaust, so any inefficient combustion process, will have. Apart from this, we find hydrogen cyanide, HCN, we find ammonia, then we can find say this aldehyde, they are known as phosgene or carbonyl chloride. See, this is a blast furnace, we find them in blast furnace, this almost all this metal plating, welding, we find a great amount of HCN being produced, say creation of explosives, NH3 explosives and dye, making. Say phosgene is chemical, see all this is blast furnace, steel industries, you can see mostly steel industry would be related to this, say this explosives, dye making, explosives industry, chemical and mining industries, say this phosgene are mostly in the chemical industries. In the chemical and other industries, chemical industries. So, you have 1 here, 2, there is 3, 4, 5, 6. These are mostly where they are from, So, related industries which are generally, this is for a general class as I have said. So, just to start the course here, what are the sources, mostly what are the air pollutants we are generally discussing about. Say the seventh is that arsenes. Arsenes are mostly, say this metal or acid processes, involving arsenic, say, so mostly say this soldering industry, soldering work, wherever there is a soldering work, arsenes would be used, would be exposed. These suspended particles, ash, soot, smoke, etc. Then solid or liquid particles produced by combustion. Liquid particles produced by combustion, mostly from different, say this mostly from, say, power plants, steel mills, power plants, then says chemical plants, etc. So here this is the suspended. I will come back to in greater detail on this, the effects of that. It's a lead. This is lead. Earlier used to be very small particles. Emitted from motor vehicles, and smelters. I think I have referred to these things in the introductory class, if you remember earlier in the classes, when we started this course. But more and more, we just, since we are coming to these areas particularly, so would be smelting of any ore, actually is that there is almost all ore they have smelting of any ore. This is most of these ores, they have whatever may be the primary mineral, of interest, there will be some complexion of lead, nickel and copper. So whatever may be the mineral, finally lead would be released. I mean, in the case of and particularly say elemental lead can be produced. Say they generally forms from say their the temperature at which they evaporate is relatively less than the other metals. So they go immediately transmit in the air. They become evaporated and finally come into the air. So this lead is known to be likely to be a potential carcinogen, which is likely to be a carcinogen, and but also it helps damaging the nervous and blood forming streams. Then the final is the ozone. ozone. It's a particularly motor vehicles. You see, the motor vehicles is a smog. Most of the smog, particularly wintry evenings. Particularly this ozone, which is formed as a means of photochemical reaction, produced due to photochemical reactions. And this, as you can see, is a motor vehicles. Mostly this motor vehicles say all this photochemical reactions, particularly says nitrate, say this nitrogen and oxygen radical finally forming during a photochemical reaction process forms this ozone, which is highly reactive. In such cases ozone is highly reactive, which can actually lead to some kind of irritation. Contrary to the popular belief, is that as we have known, stratospheric ozone is helpful for our health, but this ozone, which is formed due to remains in a combination of other gases and dust particulates, they can be toxic, they can be reactive. So in such cases, so whatever many cases, if ozone is obtained, say generally all people say is if you go to the seaside, the concentration of ozone increases, but that ozone is helpful when it is in isolation, when it is not connected in the form in a reactive manner with other elemental gases. But when they are particularly in the high speed high road junctions, say particularly during the winter evening time, when there is a dust aerosols are there, you find ozones there, you find several other substances like nitrogen dioxide, then you find some sulfur dioxide, all of them form a smog. There, in combination of all these gases and particulates, ozone can be highly reactive. So we can
Any ozone is near the seaside, and it is not harmful. But,
no, ozone is harmful. Suppose even in the seaside, if you are just near the seashore, if you are on the seashore, ozone is not harmful. But suppose you are in a seaside, you are standing near a road crossing which is very busy, extremely busy, and there is no atmospheric air movement, like there is relative calm in that particular area and high sunlight. In that cases, ozone can be harmful. Ozone in combination with other gases, reactive gases, can be harmful.
but generally ozone is stable.
Ozone is stable, but as I have said, two conditions I said. One is that increased sunlight and also increased in this particularly say stable atmosphere and increased sunlight together this can form due to this carboxyl group and also related to other presence of other substances, oxygen. This ozone would be produced. This ozone in combination with other would be reactive ozone. And ozone is not essentially, as you said, is reactive also, because it is a metastable substance. It is not stable substance at all. Ozone immediately breaks. Ozone would immediately break into oxygen under is most cases in the atmosphere, but when it is combining together, it does not get dissoluted so fast. Okay, so here this is what mostly these common air pollutants. Let me also further explain some of those, say these particulates and other things, just for your case, some the particulates. One very important thing, which is not necessarily always clear, is that in this is the particulates. I will come back to this again and again, but let me explain this one first. Particulates. So what are these particulates? Mostly the dust. What is called dust? The dust is the particles of size 1 to 200 micrometer, that is 10 to the power minus 6 meter. Particles of size belong to this category form. So this is the dust that is generally popularly we consider as a pollutant. Smoke. Smoke is the particle size, particles of size 0.01 to 1 micron. Smoke. Fumes. Fumes are between particles of size between 0.1 to 1 micron. Fumes. Mist. Mist is a liquid droplets. Liquid droplets smaller than 10 micron, not so much classified. Fog. Fog is a mist. Is a form of mist which also results in restricting vision. The aerosols aerobol suspensions either liquid or solid, and smaller than, and particle sizes smaller than, 1 micrometer. So here you can see this, these are mostly this, there is another distinction I would make here is that about the dust part. We will again come back to this, but for the time being let me explain this particulate charge. Most of this dust today is the critical dusts that we generally discuss about. The critical dust is the dust we generally discuss about is says particulate matter 10, particulate matter 5, particulate matter 2.5, particulate matter 1, or particulate matter 1.5. What is this means is PM10. The idea of PM10 is like this. The definition part needs to be explained a little bit. The particles forming a cloud particles forming a cloud where at least 50% of the particles have aerodynamic efficiency equivalent to aerodynamic efficiency equivalent to the particles having size less than 10 micron. The cloud where at least 50% of the particles have aerodynamic efficiency equivalent to the particles having size less than 10 micron and equal to 10 microns So, equal to or less than. So, this is equal to or 10 micron. So, here what it means, see this, the distinction is this, this is about the cloud. What it means by this cloud here is, this is of great importance, because most today what is the dust, in terms of dust, no longer it is known as a silica dust or anything like this. We generally, though we still content with the silica, the percentage, in mining generally whenever we refer dust as particularly the dust size, which is generally say about say 10 micron or 5 micron, whatever we say, but we do not refer what is the situation in which the particle is, that is the cloud. What it means by this is, just to explain this particular thing, PM10, try to understand in a box. Suppose you have a box, this is a box containing all this, say, suspended particulate matter. So, if you just can say that out of this, if this is the cloud contained in a box, if out of that the 50%, say if you can say a 50% of this volume contains particles which are equal to 10 micron and less, they would be referred as 10 micron cloud. That is, or we would refer them as particulate matter 10. Okay. So, not merely the size, it should also talk about the cloud. One or two particles do not matter much. So, it should have, if the particles forming a cloud where at least 50% of the particles have aerodynamic efficiency equivalent to the particles having size less than 10 micrometer and equal to 10 micrometer, less and equal. So, here this is aerodynamic efficiency equivalent. What is this aerodynamic efficiency in equivalent? Aerodynamic efficiency equivalent, that means say this the physical parameters like drag, then say velocity, then viscosity of all these particles should be equivalent to that of a particle of 10 micron size. It may be some particles, maybe say if it is not silica, it may be of some other, say, quartz particles, or other, silica is certainly a quartz particle, but say other classified particles which has the size is more, but the surface is so plain that its drag is equivalent or similar to a 10 micron material of silicon. in such cases that would also be included as a 10 that the efficiency you should have efficiency should the efficiency aerodynamic efficiency would be all important, and to deal with if this the cloud contains particles which have particles which have aerodynamic efficiency equivalent to 10 micron meter or less, they would be referred as PM10 cloud. So, this is similarly PM5, PM2.5, PM1.5. So, as you know PM5, 5 micron is less than, say, is today it is being considered that what is important is more than 10 PM10, it would generally come out with the saliva. It would not enter into the bronchial column. It will not enter the bronchial column. It's not this. It will not enter to your lung. But anything of PM10 and less, PM10, PM5, PM1.5, 2.5, all this has a potential to enter into the lung and reside there. So, anything more than that would be physically obstructed by our typical resisting mechanism, and they would not be included. So, for us the particle size which are less than 10 micron PM10 configuration, as we have said, they would be all of importance. Anything more than that will be restricted in the physiological system that we have. So, the saliva would arrest them, the nasal the fluid would arrest them, the bronchial tract would arrest them, cilia would arrest them. So, they would not be entering to the lung at all, but rest of them can enter into the lung and can remain in the lung. So, these are all the things which would be of great importance to us. Anyway, so here you can see this we have more or less explained this the typical things that we would discuss about this most of these particles and their effects, most of the particles and their effects. So, here in such cases you see this. Well, another important thing that one needs to know is this is the background emission. Background emission. Background emission. So, background emission is like this. There would be always there are some natural factors. Background emission deals with the natural factors that work as agents for generating the air pollutants, See, many of these substances are also naturally produced. Say carbon dioxide, sulfur dioxide, ammonia, then there is particularly some particulates. They are also naturally formed. What is the importance of this is carbon dioxide not necessarily is generally produced by man-made actions. Carbon dioxides are forming due to different other reasons also. Say most of carbon dioxide is also produced from marshlands. Sea is a great contributor of carbon dioxide. Say this animal, this living beings, plants, as you know, living being, plants, all of them produce carbon dioxide. Similarly, there will be many other sources of sulfur dioxide also, say natural reactions in which the soil is getting oxidized, and when the soil is getting oxidized, some of the sulfur dioxide would also come out from the soil, and that is the background emission part. So, there are two things to understand. One is that there will be always some emission resulting due to natural causes, which do not depend on any human action. They are independent of human actions, right? Even if you do not do any man-made activities, carbon dioxide would still be produced, sulfur dioxide would still be produced, particulates would still be produced. Say particularly in the desert area, say when the wind blows, the particulates come out in the environment, come out in the surface level. So that there is nothing to do with perhaps with man-made activities. So these are the background values. So when you are dealing with this kind of subjects, you must try also find out what is the background value existing. So finally what you are measuring is the total value, that is the background value plus the man-made effect or any other kind of agents that are causing it. So you must be able to calibrate for the for the background emission. The background emission should be deducted. So the background emission has so is just to emphasize this, one important aspect is that not only humans produce many of these gases which when in excess is extremely allergic or toxic to human health, right. So there may be other sources also. There are particularly say during a particularly say during a volcano eruption, in the case of a volcanic eruption, you will find lot of sulfur dioxide being produced, lot of this H2S being produced. So these would all relate to the background value. So this is what the background emission part should also be known in to understand this kind of pollutions. So here is there are different sources, but before that going to different sources, let me start the topic on this, the health effects of gaseous pollutants. Why I am discussing this before the standards is, the reason being is why I am discussing, say you might be health effects of gaseous pollutants. You might quite ask me why the health standards, the air pollution standards are not being taught before this. The reason being, once you understand the health effects, then only you establish your health standards, air pollution standards. So one comes before the other. So first of all, let us have to understand, in the first place we have to understand what are the health effects of different kinds of gaseous pollutants. In this discussion here, we will bring in some of the very important typical kinds of gases, like say this sulfur dioxide. The sulfur dioxide we will begin with discussion with the sulfur dioxide. See here, before I begin to discuss with you, there are few things that I want to mention here. One is most of these experiments which lead to explain the health effects are basically statistical studies, mostly the statistical studies. So they generally at best estimate the parameter. So they cannot say, they tell with say 95% confidence or say even 90% confidence or 85% confidence, but not at any point of time with 100% confidence that this is going to take place. There are two things different in statistics and mathematics. I mean particularly for many cases one should try to understand this. The statistics is basically a method of estimation. Mathematics, or in many cases, is the cases of determination. These are two different aspects. This has a great role in understanding environmental effects, because in all cases whenever you are discussing with the environmental effects, what we are essentially talking about, the results which are derived from a statistical study and which only points to an estimation. They cannot say with 100% confidence that this is going to take place. There is no kind of yes or no situation. Say if there is, nobody can say that if there is no pollutant and if a person regularly exercises, if the person takes a good food regularly, remains a very balanced life, that he will not have cancer. Okay. So there is no 0-1 situation. Neither one can say that if a person remains a very bad life, or say smoke every day reasonably, drink every day, that finally at this age he is going to land up with cancer. No. In all these studies, we are just trying to understand the situation, and all we are trying to understand, that with a certain level of statistical significance in that, with certain level of confidence in that, but never again think about that, we can say 100% situation. Say, one cannot say that if a person meditates every day, or even a person listens to Amrit Bachchan or any kind of, that's kind of the speeches that the holy men do, that he will not land up with, diseases or things like that. It might reduce, but 1 in 100 or 2 in 100 or 3 in 100 cases, you will find that person also is suffering from the typical diseases that the other normal people have. So it cannot be said like that. So here it is. This has a great importance. So most of these studies are statistical estimation studies. Another great important thing about all these health effects, when you are dealing with the health effects, is another very important aspect is the experiments are generally long drawn. I mean, they take a long time before one can conclude something. That, say now, just for an example, that X-ray exposure has ill effect on humans, came to knowledge 20 years after the testing began. 20 years after the testing began. So you are starting an experiment and you are trying to see the parameters, you are trying to observe, and then you find that in 20 years, it takes 20 years. It took about 20 years for people to know that X-ray can have bad impacts on human health. Exposure. So next time when the doctor says that the X-rays are harmless, don't ever believe them, because one should have minimum exposure to X-rays. Minimum exposure is all important, because it is now quite proven that X-ray, and nobody knows. Another very important thing, generally doctors would say in many cases, because doctors themselves would not be knowing this, that say low energy radiation or low energy exposures, they are not harmful. The people generally talk about that, but this is also not correct. Repetitive low energy exposure, low level exposures can be tremendously dangerous over a long time. If a person is getting used to getting affected over a long time, he might get different kind of symptoms, I mean, which can result into this. So another, this is right, okay. So this, the third one that I would also say here is, you see this another, that is generally the two, these are the two types, there are health effects. When you are discussing health effects, we generally discuss two things, morbidity and mortality. Morbidity and mortality, says one can lead to another, that is morbidity means this, morbidity means permanent or nearly permanent damage of a physical organ like lung, kidney, say digestive system, like this. Digestive means permanent or nearly permanent damage of a physical organ like lung, kidney, digestive system, like other say hormonal systems, digestive systems, etc. that may or may not lead to death. May not lead to death, say lung, ear, say nose, lung, ear, nose, physical organ like lung, ear, nose, eyes, kidney, digestive system, etc. that may or may not lead to death, So, this is called morbidity. So, if you are not hearing, suppose due to a say bomb blast, if a person loses his hearing ability, it is a morbidity that has affected him, or he is suffering from certain kind of morbidity, hearing loss, memory loss, which may or may not, I mean in most cases nobody knows for sure, in many cases may not lead to death. So, this is called morbidity. When it is dealing with which is when it is mortality, say this means collapse or total failure of the life, failure of organs leading to certain death is related to the mortality, So, this is, so increased morbidity can lead to mortality, but is not related, serially correlated. It cannot be directly correlated that morbidity would finally lead to mortality. It is not like that. So, here this is when you are dealing with these studies, we must deal with what essentially we are dealing with. We are dealing with morbidity or mortality. In most cases, say for every 300 cases of morbidity, there may be one case of mortality. So, this is the situation. So, in many cases we may not be discussing about mortality, but it can be related to morbidity related damages. Okay, we will again take this up in the class next. Okay. So we start the next class, and here we begin to study the health effects of most of these gaseous pollutants, some of the gaseous pollutants. Let me explain why how these studies, what these studies reveal as such. See the sulfur dioxide as a pollutant. So, say this is on normal persons. Yes, normal persons or subjects, so what we see here is that for a normal person, this is the challenge studies is there is normal subjects, they, for all these cases we can see there are few things. There is consistent evidence that normal persons are less sensitive to the effects of inhaled SO2. The usual contact itself, that is what is happening there. The skin is allergic to the allergen. Allergen is the spider web. The material in the spider web is the allergen, and the skin is allergic to that particular substance. So here, as the skin has already developed an allergy, similarly the throat and the passage in the throat would also generate a certain kind of allergy to that, and the allergy would lead to the constriction or reduction in the airway passage. And as the reduction in the airway passage begins, so all kind of breathing disorders begin to take place. So as I said, exercise relatively prompts far more effects. See, there's something to relate it to is the morbidity study. See, this is the morbidity studies that we have generally as morbidity studies. So the conclusion in the morbidity studies is morbidity studies say increased exposure. These are the temporary effects. The increased effects is